The dreams. The dreams.
Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. Thank you again for joining me today. Whether live or on the recording, we're going to be talking about string manipulation today, and string manipulation kind of brings us into a bit of a different area of programming than we've kind of experienced up to this point, right? We're taking on some different types of algorithms as we're approaching the idea of string manipulation. And so we're looking at different ways to work with strings. But before I get into talking about string manipulation and working with that sort of thing, I do have a couple of announcements to make in terms of, just some things that I've seen as I've been grading. Right, so we're all fully graded up through Module 4, right? Module 5 is due today. So we'll start grading Module 5 after today. But I have noticed as I've kind of gone through some of these, I see some of the same things happening over and over and over again. One, I want to remind you all to include your shebang statement at the top of all of your code. That is an expected requirement going forward. So, if you do leave that out, as some of you have seen who have forgotten and left that out, I will count off points for that, just because that is something that I'm expecting from these programs. Right. Also, another thing there is your main gate. If you're not calling your functions behind your main gate or working with your main gate at all, I will be taking off points for that as well. That is also an expectation that we have going forward, as it said in the module. Right, I am looking for these two best practices in addition to everything else that you have to do. So you just want to make sure that you're including all of these as you are, working on your assignments there. No big deal, right? And with the last couple of weeks now, I think, we've kind of gotten into the swing a little bit, maybe. Right, our first code review discussion board was last week. I saw a lot of good feedback and a lot of good input, among you all as you were kind of looking at the different ways that different people had been completing the assignment. This is an opportunity for you all to kind of help each other, right? So I hope you all kind of take it as that. Get your, if you can do your work a little early, that's great. So you can get it in there. So that way your classmates can, provide you feedback, help you out. So when the final version that you turn into me is better or works or, whatever, right? Because, you've taken the time and you've actually put effort into that discussion board. So that's something that I encourage you all to do as you're doing, as you're getting into those assignments, right? Is to take those seriously. Because there's some assignments that can really help you out as we continue to progress throughout the semester. We all kind of learn and move at a different pace, and it's helpful for us to help one another in times like these or with things like these. So I think that's all the announcements that I want to kind of clear up today. So with that being said, let's move on to the concept of string manipulation. And so we've worked with strings so far, right? We've said that basically anything that we put between quotes in a Python program turns into a string. And we've kind of defined a string for our purposes, right? We'll get more into that in just a minute. But this is a bit of a shift in the way that we think about programs and writing programs and working with programs, right? Because up until this point, primarily all of our algorithms have been numeric, right? There's some sort of numerically calculable value that we've entered into a program and we ran it through a process, and that has led to our result, right? And so it's easy to kind of talk about things in terms of, for example, our comparison operators that we've been looking at over the last couple of weeks, right? The idea of greater than and less than. Well, it's easy to kind of think of greater than and less than in terms of, a numerical algorithm, because we can look at something and say, well, yeah, 7 is greater than 3. Like, that's just a clear and present fact. But when we get into string manipulation and different areas of string manipulation, we're working with strings. So we're working with, instead of hard numbers, instead of integers, we're working with basically just characters. And we are doing some sort of process on said characters, which these processes have to run a little differently in order for them to be successful and do what we want them to do. So in looking at that, let's first remind ourselves of some definitions here. And let's talk about just what exactly is a string. So a string on its own, we've kind of worked with strings before. We've done a little brief definition of them, right? But we've never really formally defined them. So this is our formal definition of what a string is and what it does, right? So we've worked with strings in our programs, and we've put text between quotes and put that into a print statement. And we've said that is a string. But when we look at a string can just be defined as a sequence of characters. Right? Your computer in general, it doesn't know words, right? Like, it doesn't know what words mean. When you see the words on my slide right now, for example, it says, what is a string? The meaning of those words that we see here at the top of my slide, that's something that's put onto those words by us as human beings, right? Our computer doesn't necessarily have an understanding of these words in a way that we would, right? Like, what it sees in general is just a sequence of characters. And then it can take that sequence of characters and just through pattern matching, pattern recognition, it can match it up to other sequences of characters that it knows. And in turn, build words, build phrases, build things that make sense and are valuable to us. Right? And so that's a whole different thing than we're kind of accustomed to here. Because when we see a word, we know its meaning, right? But when our computer sees the word, it doesn't. So usually when I talk about a string, I tell people to we can almost kind of think about it literally, right? Like, when you are working with a string, I tell people to picture that birthday banner that you might have seen up at birthday parties, where it's a sequence of individual characters that are all held together to create a little banner by a string, by a singular string that's behind them. Right? So they're all attached. So all of these letters are attached to a string, and that string can make the words, and you can droop them and make them hang and be fancy looking and all that kind of fun stuff. So the string itself is kind of the environment in which these sequence of characters can make the words that we can understand, and as a result, characters in a string are arranged in a particular position. Which makes things significant. Right? Because once we kind of get accustomed to the fact that the different characters in this string have a home, and we can find the address of a particular character in a string and work with that from there, then we can really do as much as we want with strings. Right? It opens up doors to allow us to do all sorts of fun things. So we said that a string is a sequence, and it's a sequence of characters. And so we can see here that you can access the characters one at a time within a bracket operator. Right, so we see two variables here in our sample, and we'll get into a replit window here in just a minute, and we'll kind of see these in action. Right, well, we see a variable called fruit, and we've put into it a string that is the word banana, B-A-N-A-N-A. And then on the second line here, we see something that's just a little bit different than what we're accustomed to so far. Right, we see a variable called letter, and that variable called letter is referencing the variable fruit. So it's referencing whatever word is stored into that variable. And then out to the side of that variable name, it has square brackets with the number 1 in it. And we said that, each of the letters in a string has an address, and that address is the home of that letter within that string. And so what we have in the square brackets here is the address of the index location of that letter that is in that string, right? When we are thinking about these addresses and how we reference these letters utilizing our index locations here, we can kind of think about it like your home address, right? To where, like, if you lived at 123 Main. Yes, that is a good question, and yes, that is correct. I am getting to that in just a moment. But yes, that is correct to the question in chat. I won't read it out loud because I'm going to talk about it. So when you think about, like, say 123 Main Street, it's all the houses are on Main Street. And each of them have a different number. And one of them just so happens to be 123, and that's the one that you want to go to. And so in this case, right, we have fruit 1, we have the letter in the 1 location in the string that is banana in fruit. And one of the strange things about programming is the way that we decide to count. Because most of you probably start counting. If somebody told you to count to 10, you'd just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? But programmers, we don't start counting at 1. Right? We start counting at 0. So if we were to execute this statement here, fruit 1, and we were to evaluate the statement and return the letter, that's actually going to return the letter A. Because the letter A there is in the first index location. The letter B, the first letter of our word, is actually in the 0th index location. Because, programmers, we start counting at 0. So if we go up from here, it's 0, 1, 2, 3, 4, 5. Those are the index locations of all of our letters in our string here. And so we can look at that in a replit window, and we can actually see that happen. Right, so let's take some time and do that here. Let's add our shebang since we want to follow best practices. And let's create a function to do some string indexing. So we'll create a def string index. And this is Python, so we'll call it string index with an underscore in it. We'll bring in some kind of word through the arguments or through the parameters. And we'll do some sort of indexing, right? So for the time being, let's just look for the letter that's in index location 2. Right, so we'll create a variable here. We'll call it letter. And we'll set that equal to word, square brackets 2. And then let's return letter. We'll use a value function here to be able to do this. So we'll actually be returning a value instead of printing out from the function here as if it were a void function. So now we can add our main gate. If name equals main, we can add some kind of variable value that is going to give us a word, right? So let's create a variable called in, and let's set it equal to input, enter a word. And in is actually a reserved keyword in Python, so let's call it INP. Now we're not going to worry about typecasting here because we said previously that everything that we get entered to us through the input function comes in as a string anyway. So since we are using since we're using string manipulation here and we're working with strings, then it's going to be just fine, right? It's going to work for our purposes. So now since we're returning here in our function, I can add a print statement that has the value of string index with the argument of the inputted word that we just added to we just took from our user there. Right, so if we look at this and we run this, we can enter a word like tree. And so if we were looking at the word tree, we could look at that and we could count 0, 1, 2. And so we know that first E there is the item that is in our number 2 index location in this word. So when we hit enter here, we should expect to get the letter E as our output, which is exactly what we get. We could try that again with some different word. Let's try to do something that has some different letters. Right, let's try STREAM, stream. And so we can look at the characters here. We can count them 0, 1, 2, 3, 4, 5. And so in this case, once we hit enter, we should expect to get the R back, which is what we did. Right, now there are a couple of issues here with what we're kind of looking at, right? Like when we look at this sort of setup that we have here with just a static number in there, this is really beneficial in a limited number of situations, because there's no guarantee that your word is always going to have as many letters in it as you have defined for your address location, right? Because that's always, if we use our street analogy here, that's always going to be looking for the third house on the street. If your street only has 2 houses on it, it's going to be unhappy, right? Like if I use the word to, T-O. Well, that has a 0 index location and a 1 index location. So it doesn't have a 2 index location. And as a result, we get what we have here. Now we could put this into a try except block. Right, which is a good Pythonic way of doing this. Print. Let's say I want to call it recursive function string index, and I'll explain all this in just a minute. Input, try again. All right. So this is a try except block here, right, where we have added a couple of lines to our code here. And a try except block is kind of what it sounds like, right? We want our code to try something. And if it works, it'll do what's in our try block. And it'll give us that proper output. And if it throws an exception, it'll do what is in our except block. And so in this case, we'll just print try again. We'll call a recursive function that will allow them to put another word in, right? So if we run this now and we have the word to in there, right, it's going to try to do that. But when it fails to do that, it's going to want me to try again. And so now maybe I can put in TWO and get an O returned back to me. Now it did also print none here, and that has to do with some of the weird things that are going on here with our try except block. We can fix that. But for our purposes today, I just kind of want to bring this to your mind. This is something that we can use to do some data management, to work with some things, right? Like if you're expecting a string and you get a number, for example, right? Which could be something that's interesting, right? Like if I take this input and turn it into an integer, then that's also going to fail. So it's going to tell me to try again. So we'll revisit the try and except block in the future. But for now, I'd like to talk about some other ways that we can approach this and some other avenues via which, using this makes sense. Right? For example, if we're just looking for the first letter, right, then we know that probably pretty much all of our words are going to have at least one letter. So if we're looking for the first letter, searching for index location 0 makes a lot of sense. Right, and so that's always going to find the first letter of our word. If we're looking for a last letter in our word, then we can use kind of a static number here. Because one of the interesting things about index locations, and this is something that is true for basically every programming language, if we have a word we have index locations going forward that are 0, 1, 2, 3, etc., based on the length of your word. Right, but we also have index locations going in reverse that are going the opposite direction. So if we go back the other way, it's kind of like traveling a number line, right? If we're going forward, we're going in the positive direction. If we're going backwards, we're going in the negative direction. So our last letter is always going to be -1. And then we go back to -2, -3, -4. Right? So if we want the last letter in a word, we can address -1. And so if we were to enter in something here like, say, Godzilla, we should expect to get the letter A back. So -1 gives us the last letter. If we were to do 0, well, that would give us the first letter. And then 1 to infinity, -2 to infinity, depending on the word, is going to give us one of the letters in between. Now I'm going to comment both of these lines out for just a moment, because there is a condition that we would want to consider. And that is that, if we're taking an input, like we're doing here, like we talked about in our example there, you don't necessarily know the length of the word that your user is going to enter in. So if you want something besides the first letter or the last letter, if you want just some other letter that's in your string, you don't really want to rely on a static number. You want to rely on something that is referencing the length of that string. And that's where we bring in the len function. L-E-N, parentheses. We put our string in our parentheses here, and what pops out is some number that is the length of our string. So let's just see this in action really quickly. We'll print out len word from our function here. And we see that if we input something like treehouse, we get back the value of 9. Right? There are 9 letters in treehouse. T-R-E-E-H-O-U-S-E. 9. And so we can use that accordingly to figure out different things. Right? Because we can use that, we can bring that returned value back as an index location. So say, like we also wanted to say, oh, let's do len word divided by 2. Enter a word. Let's enter that word treehouse again. And we get 4.5. Well, now what if we did something like we imported our math library, import math. Maybe we imported math as M. And we did, say, m.seal len word divided by 2. So seal is sealing division, right? So the results of our problem here are going to be rounded up to the next whole number. So if we look at a word like treehouse now, we get 5. And so what are we trying to isolate here? Let's just try to kind of bring that back into what we're trying to do here. We're looking at that. We're looking for that letter that's in the dead center of the word, or as close to the dead center of the word as possible. And so there's actually, there's a fun little algorithm that we could do where if there's an odd number of letters in the word, we can do this sort of calculation and get the letter that's in the center. If there's an even number of letters in the word, we can do a different thing where we're getting a string slice. Which we can talk about. So, let's just kind of do that. Right, let's do that. So we can write an if conditional here, and we can say if len word modulo 2 not equals 0. Right, so if it doesn't equal 0, then we're going to return this. Right, so now if we enter in something like tree, which is a 4-letter word, we get nothing back. Right, because we are printing something here, even though we didn't get returned anything there. That was the issue from before too, by the way. But if we enter in something like treehouse, we get 5. Okay. So what if we return to the index location of word at this minus 1, right? Because we take off 1 because in our programming counting, we don't, we don't start counting at 0, or we don't start counting at 1, we start counting at 0. So that would actually be at the 4th index location. Another option here would just be to do m.floor here and do floor division, because then it's going to round down to the nearest whole number instead of up, and that's going to actually be a better in terms of evaluations that it has to make. Let's just swap that out to floor. So now it's going to return the letter at the index location of m.floor len word divided by 2, which is going to be the number 4. So at the index location of 4, it's going to return the letter that's in the dead center of that word, which is going to be H. Let's think of some other word here that has an odd number of letters. Let's try something like necktie as one word. Right, so treehouse was 9 letters, and it gave me the H that was in the middle of the letter, or in the middle of the word. And since this is 7 letters, if we were trying to do it statically, it would not work for us. But since we're doing it dynamically, based on the length of the word and dividing from that, what we should expect to get here is the K, which is exactly what we get. And so in that sort of way, right, we're starting to make our programs more dynamic. We're starting to give our programs more opportunities to do different things, because instead of just using static values for things, we're using dynamic value for things. And so let's do the other part. And to do the other part, I want to introduce another function for just a minute. Or actually, I'll leave that input and take out that print statement there. I'll comment out that print statement for just a few minutes. And I want to talk about string slices. So a string slice is a segment of a word. So when we look at our index location here, we're kind of looking at it as like, okay, this is a singular house on the street. When we're looking at a sequence or a string slice, we're basically saying this is a sequence of houses on our street. This is the 3rd through 5th houses on our street or what have you, right? So if I want to have a string slice, I can bring something in. We'll bring it in as letters. And I can set that equal to word 3:5. Right? And so 3 is the starting location where I want to start my slice. And I want it to go up to, but not include, the 5th place in our slice here. So now if I return letters here, and we did a print INP or a print string slice with the parameter of INP, we can run this. We can enter a word like Godzilla, and we get ZI, right? Because it starts at the 3rd index location, which if we look at Godzilla here, that's 0, 1, 2, 3, which is Z. And it goes up to, but does not include, the item at the 5th index location. So in this instance, it's giving me 3 and 4, not 5. It does not include the last index location. So if we added that to this string index item here, to where we could do something that says, well, if it's not an odd number of letters, give me the 2 in the middle. Right, so we can write an else statement here. And we can write a return for word. And most of this is going to be exactly the same. Word m.floor len word divided by 2. Right? If it's an odd number here, we really don't have to do the m.floor, so we can remove that here. Because you're not ending up with a decimal number there. Right? You're just ending up with a whole integer. And we want to go one more letter up. And so one of the things that might actually be smarter here is if we took this, since this is kind of getting kind of long, and just cut it out of there and pasted it into a variable. And we can call this slice start and set it equal to this. Right? But it's not quite the exact thing that we want there to get our slice. Because if we look at, say, just a random even letter value here, it would be word. So word is 4. When we do len, it gives us the entire length of the word, which in this case would be 4. 4 divided by 2 is 2. And so that would actually be this character, the R, because we go 0, 1, 2. And that's where we want to end. But the unfortunate thing about the slice here is that it's not where we start or where we end. Or it's not where we end. Neither one of the values in there is where we end, right? It is one past where we end and where we start. So for our string slice, for our slice start here, I want to subtract 1 from that to move it 1 backwards. For our slice end, since I want the 2 letters that are in the middle of the word, I'm going to take this slice start value and add 2 to it. So that's going to give me an index location that is 2 higher than the start value. And so since it goes up 2 but does not include that highest value, then that's going to give me my 2 letters that are in the middle of my word. So I'm going to go from slice start to slice end. And so now if I have a word like Godzilla, and I want to get the 2 letters in the middle of it, since it's an even number of letter word, we get ZI. But if I enter in treehouse, that's weird. Because that should have triggered our first conditional statement here. Let's try to take that not equal to and just make it a not. Is not 0. Or does it just want me to use not equal to? It wants me to use not equal. Oh, I see what it's doing. I think, maybe. You are good. Good call out. I meant to go back and do that. Good call out. It's getting late in the afternoon on a Thursday for me. I miss stuff like that. Yes, I just forgot to have the correct function be the one that's running there. I meant to go back and comment out the string slice function instead of the string index function. So now if I enter in Godzilla, we have a traceback function, a traceback issue here. It's telling me slice indices must be integers. Which, that right there is going to give me a 0.0 because we're doing division problem like we've looked at before. So I need to do that. And now it'll work. Beautiful. Yeah, remember there, one thing that I'd kind of forgotten there on the fly is that we get from this division problem that we have here, len word divided by 2, right? If you'll remember back to one of the earlier weeks of class when we were just doing standard division problems, I showed you that, if you take 2 whole numbers and it gives you a whole number output, it adds a 0.0 at the end of it. So that's what's happening here, is it's giving me the number 0.0. So I just turn it into an integer. It cuts that 0.0 off the end of it, and everything works just fine. So if we did treehouse, it should give me that H that's in the middle of the word. And if we did Godzilla, it's going to give me that ZI. So if it's an even number of letters, it's going to give me the 2 letters that are in the middle of the word. And if it's an odd number of letters, it's going to give me the 1 letter that's in the middle of that word. And so with this, we've kind of discussed the basics of string slicing, indexing, right? We've covered a lot of stuff there, and really there's a lot of stuff to talk about when it comes to strings. So I want to kind of pick and choose some things here based on some stuff that's going to be useful for your labs. One is iterating a string. So let's create a new function called def string underscore iter. And we'll bring the word in there as well. And so now that I know how to address all of the letters in my strings and or segments of letters in my strings, I can go through and I can address all of them through iteration, right? Like we looked at the while loop. Last time. So if we did something like this and we had a function where I entered a word, I could create some kind of variable. Say I equals 0, I for index, and we can write a while loop like we were learning about last week. While I is less than the length of the word. And then we can just print the letter at the current index location. So word at index location I. And then we can add 1 to the value of I plus equals 1. And so now this will go through and print out every single letter that's in a particular word that we give it. So let's comment out this function here, or this function calling that print statement. Since this is a void function instead of a value function, since we're actually printing out inside of the new function that we wrote here, I'm just going to write a function call string iter, and the input is still inp. And so now if I run this and enter in something like treehouse, it's going to give me everything in treehouse, treehouse. And we can also work with this to do comparisons and to make another string. Now, strings, interesting thing about strings is that strings are not mutable. Strings are what we call immutable. In programming, when something is mutable versus being immutable, mutable are items that can be changed in place. Immutable are items that can't be changed in place. Right? Like I can't just remove one index location from my string and it still work. It won't change anything because the string's immutable. I can't change it. I can replace it, but I can't change it in place. And so let's say I wanted to write a little function here that would take a particular letter out. All right, I could even go a step further and have like variable b here for the letter that I want to remove. And in my string here, I can have an empty string. So we can say results equal empty string. Right? And so now results is an empty string. So I have initialized this results variable. And so if I want to take some character out of a word, like let's say I want to remove the E out of the word. All I'm going to do is I'm going to look through here and I'm going to do comparisons. So I'm going to say if word index location I equals E, or no, we used B here, B, we are going to continue. We are going to do nothing. We are going to move on to the next run in the loop. Now we should probably also increment I here, so we need to add I plus equals 1. So it increments I, so that way when it goes back to the top and does the next loop, it doesn't just get stuck into a infinite loop. So then in our else statement, we can take our value of results and set that equal to what's currently in the value of results plus the letter at word index location I. And so we are completely replacing what is in this word, that's results, with what's already in there concatenated with the letter that's at this particular index location. And then we want to increment the value of I. That looks weird. Why is that? Looks like it's not on the right level there. There we go. We can fix that. And so when all that's said and done and we've gone through this, we can print results. Right? So if we went through the same thing, we looked at the word treehouse, and I forgot to add the second condition or the second parameter here. So let me add that. Let's say we're going to look for the letter E here. So if the letter is B, or if the letter is E rather, that's kind of confusing. Let's change this to E. Just for purposes here. So we're going to bring it in as parameter E, but we're going to start it with the letter E. So if the word at a particular index location is E, then we're just going to continue back to the top of our loop. It's not going to do anything. If it's something else, it's going to concatenate that letter onto results, and then it'll increment and go back up. So if we were to look at a word like treehouse, we get treehouse as our result there, right? So we've gone through and we've removed a particular letter from this word, right? And if we were to say do this with L for, if we were going to look for Godzilla, right? We would go Godzilla and we'd get Godzilla. Right? And so we could even do a thing where we have our user input the letter that we want to remove, right? Like that's no big deal. That's kind of trivial at this point that we have that ability to do that. Now, doing all of this while loop here is a lot. Like this is a lot of lines of code. And one of the things that we learn about programmers over time is that we have ways of making our lives easier, right? And so in this case, what we have is we have an enhanced for loop. So we'll call this enhanced for, and we'll take a word value and we'll take some letter in here, E, and we'll basically do this exact same thing. we'll use an enhanced for loop. So in this case, instead of doing all of this with our incrementation variable and looking for the index location and doing all of that stuff, we're just going to say for, make up some variable value. So we'll just say for letter in Word. And now it's going to perform whatever operations that it needs to perform on each letter in Word. And we can basically do what we were doing at this point here, just a little bit differently. We can just say if letter equals E. We will continue, right? We don't need to increment since we're not using an incrementation variable here, right? So we can just move on and we can else. We still need a results variable here because this is because our string is immutable. We can take results equals results plus letter. And then ultimately we can just print results. So now we see here two functions that do exactly the same thing. This is doing it with the enhanced for loop. And this is doing it through the while loop that we learned last week. And so we can verify that by just changing this function call to enhanced for and running Godzilla again. And we still get Godzilla, right? That just goes to show us that these two functions are the same in practice, but we can see that this enhanced for loop is quite a bit shorter. Quite very much very much easier. But what if I told you I could do this same thing again and make it even shorter? All right, this just gets back to the fact that there are dozens of different ways to do the same thing in programming. Right? I can even take this and basically make a function that is a singular line. Right? So I can def. We can call this replace fun. We'll take in our word. We'll take in our letter E, whatever we want to replace, and we will print the word dot replace, and we're going to replace the value E with an empty string. And I could put anything in this empty string here if I wanted to replace it with some other letter. Right, so let's just see this work now, and for some reason I put that function call in the wrong place, so let me move that around so you all have a nice copy to go back and look at. So this is just getting shorter and shorter and shorter as we go down. All right, so I can write a replace fun function here. I can enter a word, like, again, we'll just do Godzilla since we're doing that. And we get Godzilla still. Now, the benefit of this one here, again, is that, I could do it in these as well, right? Instead of just continuing, I could just add some random letter of my choosing to the new string. So these are three functions that basically do the exact same thing, right? We just get smaller and more compact as we go down. And so let me just have... We've reached our hour mark, so I'm just trying to look here to see if there's anything that I desperately want to cover in the live session today, or if I just want to let you all read about it and see about it in the module. And I think we'll leave it here for today. If I need to do a little more with this, I will. We'll put out some kind of supplement. But I think this is plenty to get you on your way with string manipulation. And so that's where we'll end it for today. We'll go ahead and, while we're wrapping up, if anybody who's here with me live has questions, go ahead and put those in the chat. If you are watching the recording today and you have questions, just send me an email or a Teams message and we can get them worked out. But we're at our hour mark, so we're at our wrapping up point for today. There are a handful of other things that I think you all could kind of pick up relatively well, like the find function and the upper function and the lower function. Right, but I think I pretty much have more or less covered everything that I have in my notes that you would need to be successful this week, or this coming week, I should say, in assignments. So we are just holding for questions in case anybody has any. And since I'm not seeing any, we'll go ahead and leave that here. Again, thank you all for watching. I'll hang out for just a couple more minutes with the music going, just in case anybody has any questions come to them. After the stream, or again, as you're watching, if you think of any questions, email them, Teams message them. We can do our best to answer them. But again, that's all for today. Thank you for watching. We'll see you next time.